Hi again. Let's talk about the readings for this week. So the goal of this week's readings is to take you from zero to being able to make some sense of blockchain in a non-hand-waving sort of way in a short amount of time. We're going to start with what is cryptography. What we need to understand is how secret keeping is embedded in human experience and some of the techniques that have been used to accomplish secret keeping. We'll barely scratch the surface in two pieces, one called A Beginner's Guide to Code Breaking and another a piece about simple substitution ciphers. And the things to take away from these two pieces are the generic idea of a key as the information you need to decrypt a message, and the pursuit of methods that are difficult to crack by people who don't have a key. So next, after that, we'll learn the difference between symmetric and asymmetric ciphers. We'll start with a conceptual appreciation of the very idea of the difference, and then dig a little bit into the math behind it. The Simply Explained video and the Khan Academy videos cover the basics in about 10 minutes. It's really quick viewing. And then we disrupt the flow a little bit with a fun radio piece by Jacob Goldstein and David Kestenbaum about a Pacific island where money once was or came in the form of enormous stone discs. The reason for listening to this piece is to plant the seed of the idea of money as information and common knowledge of a ledger, a listing of who owns what, as crucial to a money system. After this, we'll dive into blockchain proper with the first of a series of videos by Anders Brownworth. The first one's a little bit longer than videos we've looked at before. It's about 18 minutes long, but it covers a lot of territory. Anders starts out by introducing you to the idea of a hash, a thing called SHA-256, secure hashing algorithm 256 bits long. A hash is an algorithm that can process an arbitrary input. You can feed it anything, and it will yield a fingerprint string of a fixed particular length. In this case, the output is always 256 bits long. After hashes, we'll meet blocks, and then nonces, and then signings, and the idea of mining. So the first takeaway from Brownworth's video is how blocks get built. At this point, you'll hear Anders talk about hashes that start with 4 leading zeros. This just means that the hash, the 256 bits, or the 64 hexadecimal characters, that is the hash, the fingerprint, we're trying to find ones that happen to start with 4 zeros. Okay? So it's a subset of all the possible hashes. And what we do is we have something that we add to the message that we want to encode. And if we add that thing to the message, then what we get is a hash that has these 4 zeros. Now you can't compute what this thing is. You have to keep looking for it. Right? So what you do is you take the message that you want to encode and you put a nonce on the end, and then you hash it, and you see whether or not you get a hash that starts at 4 zeros. If it doesn't, you try a different nonce, and so on. So it seems arbitrary. It is arbitrary. The idea here is we've created a task that takes some time and effort to accomplish. So after we meet these concepts, we'll put them together and think about how blockchain is a chain or a linked list. So the middle takeaway is going to be how do blocks get linked in a chain so that the chain resists mutation or resists change. So part of the idea of blockchain is that it's a secure place to store things, because once something is stored there, other people can't fiddle with it. Finally, we're going to move on to the implications of blockchain being a distributed mechanism. By distributed we mean that it's not software that's running on just one person's machine. Right? There's not some central repository where the blockchain is kept, but rather anybody can have a copy of the blockchain. At this point, we've only seen the role of hashing in blockchain. We have to note right now that hashing is not a form of cryptography. So hashing, you can't dehash something. You can't go back from the hash to the thing that was hashed to get that. You can't decrypt a hash. It's a one-way transformation. So where does cryptography come into the picture? Here's the too long didn't read version. I might want to put secrets on the blockchain, right? Secrets that are intended for your eyes only. Asymmetric encryption is going to turn out to be a cool way to do this. So imagine an encryption technique that depends on two keys. Okay? One key for encryption and one key for decryption. If you send me your encryption key, then I can use that to encrypt a message which is meant for your eyes only. So the next two items on the reading list are two lectures by the incomparable Eddie Wu, a math teacher. They're a bit mathy, but they really do reward attention and give you a good foundation for understanding how RSA, RSA stands for the three guys who invented it. So RSA, public-private key encryption, and how that works. So have a watch of those. That's about 20 minutes total. And again, it's a mathy lecture, but it's worth it. The penultimate piece in our reading list, you should have a look at Satoshi Nakamoto's original paper on Bitcoin. It's very short and very dense, and you won't understand very much of it on the first read. People who are experts in this area talk about reading this paper dozens or hundreds of times, and each time they kind of understand a little bit more about it. It's not something that we will understand right away, but it's a good thing to visit, so you kind of know that you've been there, you know of it. Finally, we're going to finish with a final video by Anders Brownworth, and what this does is it brings the public-private key into the Bitcoin picture, or into the blockchain picture. And so suddenly we'll start to see the relationship between public and private keys and wallets on blockchain that lets me put things in there just for you, and we can exchange value that way. And so that'll bring us full circle, that all of a sudden we'll see the way in which blockchain can act as a public ledger in the same way that the stones on the South Pacific Island were a public ledger of who owned what value. Okay, so dive into those, and we'll talk more in a further lecture and in class.